In our Zoom class today, we would have had a class discussion about how to calculate probability of independent events, more than one event occurring. And you'll know where we left off in the Zoom class, so don't do it yet, but in a minute you're welcome to sort of like advance the slides to where we left off, finish the notes on your own. But then just don't forget that to advance through the entire Nearpod, because near the end I'll have a little discussion of tonight's learning opportunity, which could be helpful if there's any questions about that, and in case we didn't get a chance to talk about that together in the Zoom. So here are the notes just to cover this topic, just in case something went on in the Zoom and we didn't get a chance to get to it. But independent events are events where the outcome of one event does not affect the outcome of the other events. And we will be calculating probability of dependent events where one event does affect the outcome of the other event. We'll just start with this. For example, if I was flipping a coin twice, the second flip, some people have the misconception that if you flip heads 10 times in a row, that means it's more likely to keep coming up heads, or the opposite feeling that, well, it's bound to be tails now because it's been heads so many times and I know it's supposed to be 50-50. Every one of those flips is independent of the other flip. The probability is still 1/2 for each of those flips. So actually trying to understand how to calculate probability of independent events is best understood by using the problem solving method, solve a simpler problem. And so we will consider the probability of flipping tails twice in a row, just to get a good idea of how this works with a very simple problem. The probability of getting tails on one flip and then flipping tails again is equal to, if you look at the sample space, the tree diagram, if you flip two coins, in this case we've got a penny and a nickel, that would be the same as flipping one coin and then flipping that coin again. There are 4 possible outcomes: heads heads, heads tails, tails heads, which is a different outcome because it'd be heads on the penny, tails on the nickels, or tails on the penny, heads on the nickel, or we could say the first flip, second flip, but those are different outcomes, and the only one that's tails tails is this one. So there's a 1/4 probability of getting tails twice in a row. But we can find that by finding the probability of tails, which is 1/2. The probability of tails on the second flip, because it's an independent event, is still 1/2. And the product of those probabilities gives you the probability of the two events occurring in succession. We can see that by just thinking about what's the probability of getting tails on the first flip. Well, half of the time we get tails. Getting tails on the second flip is half of that half. Half of half. 1/2 of 1/2 is 1/2 multiplied by 1/2, or 1/4. It's also important to realize that one of the first things we learned when we started this unit on probability is that probability, here's our interval notation. Probability goes from 0 to 1 inclusive. Any probability is going to land from the value 0 impossible up to the value 1 certain, and most probabilities will be in between those two. So if you have a proper fraction multiplied by any other proper fraction, when you multiply them, you get a smaller proper fraction. And that makes sense, that we would have the probability of two things happening should be much less than either one of them happening by itself. It's much less likely to get tails twice in a row than it is to get it once. And so you would expect that probability to get lower. And knowing that we're supposed to multiply, that's the thing that students often forget. They know they're supposed to find the probability of each of these, but then they don't know mathematically what to do with it. Well, if you think of the 4 primary operations, add, subtract, multiply, or divide, and test each one of them, you'll see the only one that makes sense is multiply. So the probability of 2 or more independent events occurring is equivalent to the product of the probability of each individual event occurring. The probability of x followed by y is equal to the probability of x multiplied by the probability of y. Okay, the practice problems, we'll do a couple of them together. We probably did this in class, but just to be on the safe side, I'll do them on the Nearpod as well. And then after we do a couple together, you'll start to see on the Nearpod the practice problems presented on Draw It slides, where you can do it on the slide or on your notes yourself, and then do a few of them, and then you'll see there'll be a video that'll pop up on a Nearpod slide where you can check your work. And that'll be a good way to get the practice. Don't forget that at the end of the Nearpod, I'm going to talk about the learning opportunity a little bit. Okay, so it's common for on probability problems where you'll be calculating probabilities dealing with decks of cards, and not everyone necessarily knows what's in a standard deck of cards. There are 4 suits: hearts, diamonds, clubs, and spades. There are 13 cards in each suit for a total of 52 cards. So if we want the probability of picking a king from a standard deck of cards, which is shown, and then rolling 1 die and getting an odd number, it's equal to the probability, let me write it down here, probability of king followed by an odd number on a die is equal to the probability of picking a king multiplied by the probability of rolling an odd number on a standard die. And the probability of a king, you see the 4 favorable outcomes here. Out of 52 possible outcomes, favorable to possible is probability. We could have made it simpler by realizing that all of these suits have the same probability, 1 out of 13, and we see that this simplifies to 1 out of 13, but I'm just setting up the expression as if we didn't notice that at first. Multiplied by the probability of odd, when we know the sample space for a die, all the possible outcomes, 1, 2, 3, 4, 5, 6. The odd numbers by definition are the ones that are not multiples of 2, so the 1, the 3, and the 5. So there's a 3, 6. I'm just going to write it in not unsimplified form. Now, we know that when we multiply fractions, numerator multiplied by numerator over denominator multiplied by denominator. But if we don't simplify first, we make it a much harder computation problem, which is why you can take any numerator and simplify it with any denominator. You can factor out any common factors. I could do the 4 and the 6. It would make more sense probably to do the 3 and the 6. Realize that 3 6 is 1/2. 4 52nds, even if you didn't realize that 52 was a multiple of 4, you start with 2 and you get 2 26, and then you realize you can go again by factoring out 2 halves and get 1/13. So if you do that simplifying before you multiply, you make the computation much simpler. I would recommend doing that on the assignment tonight. So 1 times 1 is 1, 13 times 2 is 26. And if we had done the 12 312s, I mean, we would get to 1/26 eventually with a lot of simplifying, but it's a lot easier to simplify before you multiply if you notice that opportunity exists by looking for common factors.